Okay, so we have two solar panels here. This one is a 100 watt panel, and it's wired, goes inside the, well, not much sun at all. So I'm gonna go in and I'll show you how those two panels are hooked up to two 12 volt batteries. And the wire comes in through the window and into these are marine batteries, and it's got a control charger. 100 watt comes into this one, and it's hooked up to this 12 volt 30 amp digital solar charge controller, and it's reading 12.7 volts. It's a SunForce brand.
This is a 100 watt panel. This should be producing like 5 to 7 amps of power right now. And your regular car battery charger is 6 amps. So this is the reason why you need to know your energy budget and plan for 3-day storage for exactly days like this. I was really hoping I could come out here and show you some really cool demonstrations on with the sun shining and stuff like that, but it also works as well to understand that as part of being off the grid and part of with solar panels, you have to understand that that's why you need 3 days and then times that by 10 in energy storage, because if you have to go 3 days, you're going to kill your batteries. You see where I'm going with that? And this is the perfect example of this is why you need to have...
Yeah, but that's on the assumption that your only charging method is solar.
Correct. It doesn't matter. I mean, you can charge up, you can run your generator 4 hours a day. I'd prefer not to. So again, when I came in, this was 12.5. It's getting less than half an amp, but it's enough that it is charging that deep cycle battery. To understand just the little things that you plug in. Remember, this is only a 200 watt inverter. So
That's
amps.
That's you charging your little portable vacuum.
Yeah.
Right?
So that's my little portable vacuum right there. It's charging it right now. Okay. Now I want to show you something. I have my phone. You were out here. So I plug my USB cable into here and I plug my phone in it. And the amp hour difference was 0. My phone was charging. So plugged into the wall, this uses the same amount of power as it's charging.
Wow.
Or no?
When it's not.
Strange, eh?
Weird.
Yeah, because the power is coming from the unit, not from the phone. It's
Agreed?
Let's find out.
It's got to warm up too now.
Yeah. So now the fan just kicked on because it's warming up. It's a 23 watt,
How many watts is it burning?
13 watts, but look at the amps. Just to fire it up, took more amps.
Cover it. Turn it on
Oh.
and cover it.
Remember, this is all off battery power right now. That's why you never put on
Yeah,
CFL or any bulb.
Cuts it down.
If you're
Nothing.
designing, if you have the opportunity to design or the opportunity to change them out, I swapped all my light fixtures in my house for open light fixtures. Cheap, they're just cheap ones. That's a regular light bulb,
The socket's broken.
60 watts, and it draws, what is that?
6.6.
6.6 watts, and it draws 0.6 of an amp. Covered?
Oh wow.
It just
Uncovered.
cuts it in half.
Covered? Right? I'm just showing you the difference in the light. So I turn that off.
I think it's down in the basket.
Incandescent?
So you can see I'm pushing 137 volts out of the thing, 0.69 of an amp. It's using 78 watts. That's what you're looking for. How much does each appliance have? If I want to go off the grid and I need an energy budget, how much? And this is what this little meter is the most
There you
watts.
LEDs.
Nine.
go. Oh, I. Amazing.
So think of 60 watts versus 8 watts times the amount that I said on the light bulb demonstration of the cost, just by changing to these, which these don't get hot.